Allow us to give facts and extra knowledge first. Do you know what the census is? A census is an official count of a country's population, as well as a systematic process of gathering, recording, and analyzing demographic, economic, and social data about its residents.
That fact plays an important role in our topic.
Article 1, Section 2 of the U.S. Constitution mandates that an apportionment of representatives among the state must be carried out every 10 years. Therefore, apportionment is the original legal purpose of the decennial census, as intended by our nation's founder. Many decades ago, in order to get a record for the United States Census, people would have to go door to door. It wasn't that complicated until their population grew. Therefore, it took them a lot of years to comply all the population, close to the deadline. And that's a problem. The Census Bureau had to think of something, a new method that would fix the problem they are facing. So, census should be fast and accurate, as it is vital for our country's well-being because it forms the basis for decision-making. Ultimately, a census is both accurate and fast, provide a true and current picture of the population, which is essential for effective governance and equitable societal planning. An idea struck them. The U.S. Census Bureau took the 1880 census and then held a competition to whoever could solve it all fast would be the winner. This competition happened back in 1888. That also serves as a motivation and purpose at the same time for Hollerith. During his time, before he invented the tabulating machine, as stated, the core process of census was manual enumeration and tallying. Census takers, often referred to as enumerators or marshals, would travel from house to house and record information about each person on paper forms.
Because it's done manually, they found many problems such as it was incredibly time consuming, and at the same time, manual counting was highly prone to human error, and the sheer volume of data made it difficult to detect and correct mistakes.
So the brilliant-minded Hollerith created the tabulating machine that will drastically speed up and automate the process of summarizing and analyzing large amounts of data, specifically for census. After that, the counting, sorting, and summarizing data from punch cards became automatic.
The machine's core function was to read data from punch cards using electrical circuits. The machine will detect a hole in a card and sense the presence or absence of these holes. It would complete a circuit that would advance to a mechanical counter. This allowed the machine to automatically count, sort, and compile data from around 7,000 of cards with much greater speed and efficiency than manual methods.
Let's dive deeper. How do tabulating machine work? We'll be discussing the functions of these three parts and under these parts. Number 1, punch card machine. Number 2, reading device. And lastly, number 3, electrically operated sorting box.
Number 1. Punch card machine. After gathering information from the handwritten punch card, you'll put it under the punch card machine where it will punch holes through the card, which serves as the punch card encoder. Other than that, there are guide holes for accuracy. Number 2. Reading device. Now that we have punch holes through the card, it is time to put the card on the reading device. After that, pull down the hand-operated press. The pin box that has a lot of needles will go through the holes of the card. Then the liquid mercury will go through those holes and through the sensing station with mercury cups, where the information would go to complete a circuit, transferring the data to the dial counters.
Now, how do the dial counters work? The dial counters use a ratchet system, read and show the information on what the data the reading device reads. For further explanation, I'll be showing a video that gives an example on how dial counters work.
So only the ones that made it into the mercury would then have current going along that wire. It would then feed into all these dials. These dials would use like a ratchet system. So each time they got a bit of current, they would ratchet one over, and then you just feed in loads and loads and loads of cards, and once you were done, you'd read off all the totals from this.
Why are there like 30 different dials? Are they counting like the various different questions that people were asking?
So all those dials, you could set one to just keep a tally of all the cards which had a particular answer to a particular question.
So I say like, I live in Montana, and it's like the Montana dial.
Yeah, the Montana
up.
dial goes up. Or
Okay.
how many people answered that they were a farmer.
Okay.
And at the end, it will tell you of all the cards you put through, this many said farmer. But you could actually rig some of them to do and statements. So if you had a certain disease, and you were a farmer, and you lived in a household with someone, right? And so some of these would only increment if a combination of needles or whatever they are made contact.
Number 3. Electrically operated sorting box. While the dial counter does its thing, the sorting box detects where the card would be placed through the wire, connecting the electrically operated sorting box and the reading device. The lid will open itself after the data is analyzed. In conclusion, with this invention of Herman Hollerith, this new method helped them to save time and labor of the process.
During World War II, the United States faced the challenge of carrying out faster and more accurate military calculations, especially for ballistic tables and other complex problems. Manual computation was too slow and prone to errors, so a new solution was needed.
Howard Aiken, a professor from Harvard, proposed building a machine that could perform these calculations automatically. With the support of IBM, his idea was completed in 1944 as the Harvard Mark I. The machine itself was massive. It became one of the earliest automatic digital computers, and among the people who worked with it was Grace Hopper, who later became a pioneer in programming.
Fun facts about computer before, like the Harvard Mark I, is really massive. Like in 1947, Grace Hopper and her team at Harvard University found that a real moth trapped inside the Mark II computer was causing it to malfunction. They taped that insect into the logbook, being the note, first actual case of being bug found, and that event became a legendary story that solidified the term bug used to describe an error in computer programs. Howard Aiken also got inspired by Charles Babbage. Analytical engine, Aiken envisioned an automated electromechanical calculating machine that could reduce human error and handle the vast computations required for advanced physics and mathematical problems. And that is the birth of the Harvard Mark I. Later on, they don't just use this personal computation and research as it solves advanced physics and engineering problems. It became a helpful tool, particularly for the US Navy. It works for instrumental in tasks like creating ballistic tables for artillery and assisting in the calculation for the Manhattan Project. The goal was to automate the work of human computers and eliminate the errors that came with manual calculation.
The Mark I could automatically execute long sequences of arithmetic operations without manual intervention. It performed the four basic arithmetic operations, which are addition, subtraction, multiplication, and division, and handled more advanced functions like logarithms and trigonometric equations using built-in routines.
It could do addition and subtraction for 3 seconds, multiplication for 6 seconds, and division for 15 seconds, as well as more complex functions like logarithms and trigonometric operations, but it will take a minute. So this was a huge advance over doing things with pencil and paper, but it was a slow work.
It could store numbers and intermediate results in its registers, making it capable of sequential step-by-step problem solving, operated via punch paper tape and switches. It could run continuously for days without error, a major leap compared to manual calculations.
Harvard Mark I is electromechanical. That means that it's full of gears and motors, cams and levers. This is like a huge mechanical calculator, except that the sequence of operations that it was to perform, what we would today call the program, was punched into paper tape. These are their registers. Each one contains one decimal digit, and those wheels would all turn independently and accumulate values as arithmetic operations were being carried out. The dials with the knobs on them are where you could put in a constant, so you can see each one is a little knob and it has 10 positions. If your program required a value of pi, let's say you could dial the values of the constants in there. This part of the machine is where you put the punch paper tape, which contains the program. To make it automatically, you can punch many paper tapes and scotch tape together to make a continuous loop. In this part and the right part of the Harvard Mark I, you can see these electric typewriters. These were used to print the output of the machine.
In conclusion, the machine was used mainly during the war for ballistic calculations, trigonometric functions, and scientific research. Although it was eventually replaced by faster electronic computers, the Harvard Mark I demonstrated that machine could handle complex work automatically and laid the foundation for the development of modern computing.